In this module, you will learn to justify the truth value of a compound statement and identify quantifiers in mathematical statements. We know that a compound statement is a combination of two or more simple statements using words like and, or, and so on. Such words are called connecting words. Let's consider the statement 24 is divisible by 2 and 4. Can you say the truth value of the given statement? In order to determine the truth value of the compound statement, we first need to find its component statements. The component statements of the given statement are 24 is divisible by 2. 24 is divisible by 4. The connective word is and. A compound statement with the connective word and is called a conjunction. The truth value of a conjunction statement depends on the truth values of its component statements. The truth value of the conjunction is true if the truth values of all the component statements are true. The conjunction is false if any one of the component statements is false. Let's consider the component statements of the given compound statement again. We know that both the statements are true. Therefore, the compound statement is also true. Let's consider another compound statement. 9 is an odd number and a prime number. The component statements of the compound statement are 9 is an odd number. 9 is a prime number. Statement P is true, while statement Q is false. Therefore, the compound statement is false. Please remember that every statement with the word and cannot be considered a conjunction. For example, Jammu and Kashmir is a state of India. In this statement, the word and is used to combine two words and not two statements. Therefore, the given sentence is a statement but not a conjunction. Let's look at the given compound statements. In both the sentences, the connective word used is or. A compound statement with a connective or is called a disjunction. Let's determine the truth values of the given statements. Here are the rules that we will use to determine the truth value of compound statements with the connecting word or. A compound statement with or is true when at least one component statement is true. A compound statement with or is false when all its component statements are false. Let's begin with the first statement. 24 is a multiple of 2 or 4. First, break the compound statement into its component statements. Here both the component statements are true. Therefore, the compound statement is also true. Next, the component statements of the compound statement, a triangle has 3 sides or 4 sides, are: a triangle has 3 sides. A triangle has 4 sides. Statement P is true, while statement Q is false. Therefore, the compound statement is true. Let's look at another example. Plants do not take carbon dioxide or do not give oxygen. The component statements of the given statement are: plants do not take carbon dioxide. Plants do not give oxygen. We know that both the statements are false. Therefore, the compound statement is also false. The connective or in a compound statement can be either exclusive or inclusive. Let's first consider the statement, Ramesh will go to Delhi by flight or by train. In this case, Ramesh cannot go to Delhi by both flight and train. He can go by either mode. If he travels by one, he cannot travel by the other at a given time. In such sentences, or is exclusive. In the next statement, Rohit should have a voter card or a passport for identity proof. He may have both, and having one does not exclude the possibility of him having the other. Here, or is inclusive. We have seen compound statements with the connective words and, or. In mathematics, we come across statements that contain phrases like for all, for every, for some, there exists. These phrases convey the idea of quantity and refer to a specific collection of objects. Such phrases are called quantifiers. Quantifiers such as for all, for every, and for no are called universal quantifiers because they make an assertion about every member of the universal set under consideration. The universal quantifier is denoted by the symbol shown. The quantifiers there exists and for some are called existential quantifiers. The existential quantifier is denoted by the symbol shown.